there is a horizontal ground, which is QR line on the horizontal ground, the dotted plane here, and that which means this quadrilateral is an inclined plane. PQ is 60 while PS is 40, and then angle PQR is 30 degree. Angle PRQ, so you need to connect them, is equal to 55 degree, and then finally angle QPS. This angle is 120 degree. In order to label clearly, so we separate to two angles. By angle sum of triangle, we know that this is 180 minus 55 minus 30, so we have 95 degrees here. So the total is 120. This is 95 degrees, so this part is 25 degrees here. So that's all for this inclined plane. Then we are going to find out RS. So RS is on this inclined plane. We better, it may be like this with point P, S, R, and Q. 30 degree, 55 degree, 95 degree. So in order to get RS, it is in right hand side this triangle. But it seems that the information is not really enough. We only have one angle together with one side. So we better look at another triangle first. In this triangle, we have all the angles and also one line, one side. So it's enough for us to get all the length here if we want. So of course we want to know more about PR because it's one of the edges of this red triangle. By knowing this, then we can find SR. So our first target is to find out PR. After that, we try to find out SR, our target. So consider triangle PQR. We have to use this length PR. We have two together with our target. We have two sides and also two angles. So we better use sine formula. Sine formula, we have sine 30 degree to its opposite side. That means to our target PR is equal to sine. What we have is 60 degrees, so we choose 55 degree here to 60 degree. So PR is equal to 60 sine 30 degree over sine 55 degree. PR is 30 divided by sine 55 degree. You may use calculator to calculate the value or just keep it like this first. And now we can focus on the red triangle. We have 40, we have 25 degree, we have PR also, which is 36.6 something. In order to get our target SR, so we including our target, we have 1, 2, 3, 3 sides with only one angle. So we have to use cosine formula. In cosine formula, we have only angles here, so C represented by SR. RS squared is equal to NR2 sides 40 squared plus PR squared minus 2 times 40 times PR times cosine 25 degree. PR just means 36 point something, so we can use calculator for this whole part. We get RS squared is around 285.9074 something. So RS is equal to square root of the result, 16.90879944. That means 16.9, correct to three significant figures. If you solve part A, then part B is so straightforward. They just ask you to find the area of this paper card. That means the area of blue triangle together with red triangle. We know pretty much about these two triangles. For any triangle, we know that the area is equal to 1 over 2 AB sine angle C. So with this angle, with these two sides, so this is angle C, and then we choose this is A and B. With this angle, we can choose 40 as A and also our PR be B for the red triangle. So our strategy is fixed. In part B, the area is equal to 1 over 2 60 times PR, that means 36 point something, times sine angle between them, 95 degree. and then plus the red triangle area 1 over 2, 40 times PR again, times sine angle between them, which is 25 this time. So the total area is 1404.069236. That means 1400 cm squared, correct to three significant figures. Now it's given that the angle between the paper cut and the horizontal ground is 32 degrees, which means that if you project P to the horizontal ground, there is a projection point P prime, which is P prime is the point on the horizontal ground which is closest to P. And then they say that the angle between the paper cut and the horizontal ground, from point P we draw a perpendicular line to QR, and then from this intercept point we join it to the projection point of point P. Then this angle is 32 degrees. So basically it gives you a right angle triangle with 32 degrees here. What it's asking is about the shortest distance from P to the horizontal ground. That means the distance from P to P prime here is the shortest distance. Let's draw the right angle triangle cross section. P here, and then the vertically projection point P prime, vertically downward point P. And the intercept point, just let it be M. And then we know 32 degrees here. They are asking for the shortest distance, that means P prime here. We want to get X. What we know, we can find out PM because it's just a perpendicular line here. So we draw PM on our graph with 30 degrees, with 60 is a special angle, so I know that this is just half of 60, it is 30 directly. But anyway, in our presentation you may say that M be a point line on QR such that PM perpendicular to QR, or you may say that M is the perpendicular foot from P to QR. So what we want to say is we know PM, so we consider this right angle triangle with opposite side and hypotenuse. We use side ratio. Side 30 degrees is equal to PM to 60. That means PM is equal to 60 times sine 30 degrees. You use calculator, you will get PM is equal to 30. After that, we go back to our cross section here. Our target is to get X. That means P prime. To this angle, we have opposite. We also have the hypotenuse, so we use sine ratio once again. Sine this time is 32 degrees is equal to X divided by 30. So X is 30 times sine 32 degrees. X here, that means the shortest distance we are calculating. So shortest distance is around 15.89757793. So 15.9 cm. Correct to three significant figure. Now is the most difficult part of this question. Someone say that the angle between RS here, and the horizontal ground is at most 20 degrees. Is that claim correct? So I think the most straightforward method is to calculate the angle between them. So the calculation is a little bit like C1. The key point is S. We need to use the angle. Talk about the angle between RS and the horizontal ground. Then we need the projection of S on the horizontal ground, such that RS prime representing the horizontal ground, and then the angle between a line and the plane. That means the angle between SR and RS prime. So that's what we need to find out. But before that, we need to find out what is the height of SS prime here. So the calculations are exactly the same as we finding P to P prime. Now I want to find the perpendicular foot here, so I don't let M but I let N here is the perpendicular foot. It depends on the shape. Maybe it's outside. It's maybe possible the quadrilateral is something like this. So S here and then it's line outside, but it's totally fine. We mark N and then we say that N is a point such that Q and R are collinear. At the same time, SN perpendicular to QR. I don't say that it's line on QR. Maybe it's because it's on the production line of QR. So now we are going to get SN. If we draw from figure 1, so maybe N is somewhere here, it depends. So we need to find out how long is Sn. There are a few methods for you to get Sn. For example, you may use cosine formula to get angle PRS, and then together with this angle, you can compare with the hypotenuse here to get the opposite side. Or you may break it down to two right angle triangle here. So Sn is the height PM and then minus the vertical height here. Because it's easy to find out this angle. Angle MPR is equal to 35 degrees. So if I use the second method, Sn is equal to PM, that means again it's 30 and then minus, this is 60 degrees while this one is 40, so we are talking about 40 cosine 60 degrees, that means 30 minus 20 is equal to 10. So if we consider the green cross section here, it is a right angle with S and N here, while this one is the projection on the horizontal ground. Don't forget the angle 32 degrees is still active. So we have Sn equal to 10. So our target SS prime is equal to 10 sine 32 degrees. 5.299. It's very close to our final answer. We already know this section is 5.299 something. So if we have SR, then we can get the angle of inclination, the right angle theta here. SR we already found is 16.9 something. So we can draw our conclusion. Let the inclination, the required angle, be theta. So we have opposite, which is the height here, and together with the hypotenuse, so we use sine ratio. Sine theta is equal to opposite SS prime divided by our SR. So we just substitute the value 5.299 something and then over 16.9 something in your memory slot. Then shift sine, we get theta is equal to 18.26 something degree. And then compare with our target, compare with 20. They say at most 20 degrees. The fact is less than 20 degrees. So we find out that it is correct. The claim is correct.